Hi, welcome to Marker Board Videos. Today's video is the next in our Math in Minutes series, Algebra 1, and we're going to talk about how to add and subtract polynomials. My name is Nancy Foote. Let's get started. Sometimes when you're given a problem, you're given parentheses. Sometimes those parentheses are important, and sometimes they aren't. What you have to look is what's happening in between the parentheses to tell you if you can remove them from the parentheses without doing anything, or if you need to make a change. And what this tells me is I have 6r plus 3 plus, and if you will, you can imagine a 1 there. 1 times r plus 8. Well, 1 times anything is itself. So in general, when you see a plus here and no number here or a 1 here, you can go ahead and remove the parentheses. The next step is to combine like terms. And that's one of those things that people tend to get a little confused about. So let's look at like terms. Like terms means there are things that are attached to each other and they're identical. In algebra, we look for variables or letters. In this case, this is attached to an r, and again there's an invisible 1 attached to an r, so those are like terms. 3 is not attached to any variable, nor is 8, so those are like terms. So if you add 6r plus 1r, you get 7r, and if you add 3 plus 8, you get 11, and now you have added those two polynomials. Again, sometimes you need to leave the parentheses alone for a few minutes until you do something. It depends. And I would like to help you figure out when you leave it and when you can ignore it. Well, what we have here is an invisible 1. We have an invisible 1 here, and 1 times that is exactly that. So we're just going to take that out of the parentheses because it's all times 1. But this parentheses is times -1. The sign always stays with the number. So it's not really -1 times all of that. It is, but it's -1 times that. So the easiest way to do that is to distribute the -1. By multiplying each of these by -1, what you actually do is you change the sign. So this has that invisible plus sign in front of it. 3w squared becomes -3w squared. 7w, positive 7w, becomes -7w. And 5 becomes -5. 5 times -1 is -5. Now let's look at the variables. Here's my w squareds, and I have 2 of them. So let's put them together, keeping that negative sign with the 3. The sign stays with the number. So 7w squared minus 3w squared becomes 4w squared. And now we're done with our w squares. I like to actually cross them off when I'm done because I have a tendency to skip things and forget them and think I have them and I don't. But by crossing them off, I know I'm done. Next, we have a 7w and a -7w. And those are the only ones that just have w. W squared and w are different variables. So we're going to say plus 7w minus 7w. Well, when I take 7w minus 7w, I get 0. I'm going to cross those off. Not important for me to write 0, just important for me to know the number is 0. And finally, I have -9 and -5. No variables, so those go together. Now here's one of the things that I've learned quite a while ago, and if you have not watched the video on adding and subtracting integers, please watch it. These two numbers have the same sign. They have the negative sign, but they're both negative. So add 9 and 15 and you get 14, and you keep the sign, which is negative. So when you combine this whole mess, it becomes pretty streamlined and pretty much easy. Let's do a couple of more problems. It won't take you long to catch on to this, and as I said, by the time you finish watching this video, you'll find adding polynomials and subtracting polynomials are a piece of cake. It's not a big deal. 7h squared plus 9h plus 1, and to that we're going to add 6h plus 6. Again, the first polynomial, because there's no number in front of here, it's an invisible 1, we can simply take out of the parentheses because multiplying anything by itself is the same thing you started out with. Now I have a plus sign here and an invisible 1, so I can simply take that out of the parentheses because 1 times 6h is 6h and 1 times 6 is 6. And now I can start my scavenger hunt for like terms. I have a 7h squared, and I don't see any other h squared terms, so I'm just going to write 7h squared. Now here I have 9h and 6h. The sign stays with the number, so it's plus 9h plus 6h. If I want to combine those right now, let's bring the 7h squared down. 9 and 6 is 15, and bring our h along with it. And then I have two numbers without variables. They're constants, 1 and 6. Again, I keep the sign with the number, so the plus sign stays with the 6, the plus sign stays with the 1. 6 and 1, 7. And I've simplified, or I've combined those polynomials. 9v squared plus 3v plus 9 minus 3v squared plus v plus 4. If you want, pause the tape now, pause the video now so you can work out this problem, and then restart it once you have it worked out to see if you've done it correctly. There's an invisible 1 in front of here, so that means this all is times 1, which means I can simply remove the parentheses. You always need to check. Sometimes you're going to have another number other than 1 there, in which case you'll need to distribute. This is a negative 1 times here, so negative 1 times 3v is negative 3v squared. Sorry, negative 1 times 3v squared is negative 3v squared. Negative 1 times v is negative v. And negative 1 times 4 is negative 4. You'll notice multiplying this by a negative 1 changes the sign of everything inside the parentheses. So now let's go on our hunt for like terms. 9v squared minus 3v squared. And I think that's all I have for that. So 9v squared minus 3v squared. 9 minus 3 is 6, and the v comes along for the ride. Then I have 3v minus 1v. The sign stays with the number. If it helps you to write the 1v, go ahead and write the 1. That certainly is just fine. 3v minus 1v, 3 minus 1 is 2. The v goes along for the ride. And finally I have plus 9 and minus 4. So 9 minus 4 is 5. Again, the negative sign stays with the 4, and the positive sign, the plus sign, stays with the 9. And now you're done. Let's do a couple more just to make sure that you've got it. I'm pretty sure you do, but let's do a couple more. We have 2h squared plus 5h plus 6 minus 5h plus 2. I see the minus sign, so I know I can't simply remove the parentheses. I see a 1 here, so I know for the first polynomial I can simply remove the parentheses. That's not a big deal. This is minus 1, that invisible 1 is there, times everything in there, which means this positive 5h becomes a negative 5h, and this positive 2 becomes a negative 2. Now sometimes when you combine like terms, you'll see there's only one thing. There's no other h squareds. So you just bring it down. You don't have to do anything else with it. 5h and negative 5h, which I know is going to be 0, but sometimes my teacher likes me to show my work, so I'm going to write that. So it's 2h squared. Do I need to write 0h? No. 0 times anything is 0. So those are done. And then I have 6 minus 2 plus 6 minus 2. 6 minus 2 is 4. And I'm done. That's my answer. One last problem just to make sure. Let's make it a big, ugly one. Let's start over here since there's a lot we're going to do. 6p cubed plus 9p squared plus 8p plus 3 minus p cubed plus 5p squared plus 4p plus 3. Okay, there's a 1 in front of this one, so I can simply remove it from the parentheses. 6p cubed plus 9p squared plus 8p plus 3. This one has a negative 1 in front of it, which means this whole thing is multiplied by negative 1. So it becomes negative p cubed minus 5p squared minus 4p minus 3. And now we're going to put them together. 6p cubed, where's my other p cubed? Here it is, minus 1p cubed. So 6p cubed minus 1p cubed. I know that's 5p cubed. P squareds. 9p squared minus 5p squared. Let's cross those out because I'll get confused. Plus 9p squared minus 5p squared. 9 minus 5 is 4. 4p squared. Now my p's. 8p minus 4p, that's a positive 8. Negative 4. 8 minus 4 is 4p. And finally, what I have left, plus 3 minus 3. 3 minus 3 is 0. I don't need to write the 0, and I'm done. If you have any questions or need any assistance, please email me. Have a great day.